Example 1. Drug testing of job applicants. Refer to the table below. If one subject is randomly selected from the 555 subjects given a drug test, find the probability of selecting a subject who had a positive test result or uses drugs. So we first need to investigate this table. So if you notice, the first row represents subjects uses drugs. The next row below it is subjects that does not use drugs. Now over here, the first column says positive test result, the test that shows drug use. And then the next column says a negative test result, where the test shows no drug use. So if you look here, with having a positive test result and the subject uses drugs is a true positive, and there's 45 of them. Right below that, we have a positive test result, but the subject does not use drugs, is a false positive. Therefore, we have 25. Now for the next one over here, we have a negative test result where the subject uses drugs. Therefore, this is a false negative, and we have 5. Then we have a negative test result, and the subject does not use drugs, is a true negative, and we have 480 of them. So it's important to first identify and understand the table first. So you want to read it out loud. Now, the numbers in red or bold correspond to positive test results or subjects who use drugs, and the total of those numbers is 75. So if we add up 45 plus 25, which is 70, plus 5 gives us 75. Now, we want to refer to the table and carefully count the number of subjects who test positive, which is the first column, or use drugs, which is the first row, but be careful to count subjects exactly once and not twice. Now, when adding the frequencies from the first column and the first row, include the frequency of 45 only once. So in the table, there are a total amount of 555 randomly selected objects, which is what was stated in the question, but to confirm that, we need to add up all those numbers. So 45 plus 5 plus 25 plus 480, which is equal to 555 randomly selected subjects. Now, we want to find the probability of event A occurring or event B occurring, and that's the formula is the probability of event A plus the probability of event B minus the probability of event A and B. So, if we want to translate this into the question, we're going to say we're looking for the probability that there's a positive test result or the subject uses drugs. So this would equal the probability of the positive test result plus the probability of the subject use drugs minus the probability of the positive test result and the subject uses drugs. So now we first want to identify the probability of a positive test result. Okay, now let's go back to the table. The probability of the positive test result is taking 45 and then adding 25, because that is the column that represents the positive test result. So 45 plus 25 is equal to 70, and then we're dividing it by the total of the randomly selected subjects, which is 555. Okay, now we want to find the probability that the subject uses drugs. So that means we're looking at the row. So we want to add the values in the row. So the subject that uses drugs is 45 and 5. So we take 45 plus 5, which is equal to 50, and we divide that by 555. Okay, now we need to find out what is the probability of the positive test result and the subject uses drugs. Well, that means what number is applied to both scenarios? That means that 45 is the number that a subject uses drugs and is a positive test result. So now we write that as a fraction of 45 over 555. Okay, so now looking at the formula, remember that we have the probability of the positive test result or the subject uses drugs, again, is the probability of the positive test result, which we found to be 70 over 555. So let's take a look at that. So again, the probability of event A is the probability of the positive test result, which was 70 over 555. Plus, now we want to find the probability of that event B, which is the subject used drugs. So the probability of the subject used drugs, which is 50 over 555. And then we're going to subtract, okay, now we're going to subtract the probability of A and B. So the probability of a positive test and a subject uses drugs, we found that to be 45 over 555. So that is what we're subtracting. So now we're getting 45 over that. So we have a common denominator. So with the common denominator, we can say 70 plus 50. Once we add that, we get 120 minus 45 gives us 75 over 555. And that equals 0.135135, and then rounding it to 3 decimal gives us 0.135. Now I want you to notice here that you see how we added 45 in both of the first two probabilities. We can't count that twice, so that's why we're subtracting this in the formula. So we're subtracting one of the 45s to then get the probability. So that means that the probability that you have a positive test result or the subject uses drugs is equal to 75 over 555, which is equal to 0.135.